modeling, simulation, and experiments of a flexible track robot over rigid horizontal and inclined surfaces. In this video, we present a two-dimensional driving mechanics of a tracked small robot over a rigid surface. Our model accounts for the non-uniform distribution of the normal forces along the track. We made a comparison between the model we developed and the simplistic two-point model. We compared both to the experiments we performed. In order to compare the models with the experiments, we had to calculate the inertia moment of the robot and the coefficient of friction between the tracks and the surface. These values were calculated using experiments that will be presented now. Evaluating the friction force as a function of the speed. To evaluate the friction acting between the tracks and the panel, we developed a traction system to pull the robot at different speeds while measuring the traction force. To calculate the inertia moment of the robot, it was attached to a rotation axis, as illustrated, and allowed to freely oscillate in small amplitudes while its position is measured using the OptiTrack. The first simulation focused on measuring the robot's turning radius. The difference between the simulation to experiments was 1.4% for the turning radius and 0.3% for the angular speed. In this experiment, the turning radius of the robot and its turning speed were measured on a surface inclined by 10 degrees. The turning radius and speed were also very similar between the experiments and the simulation. In this experiment, we compared our robot model to experiments where the robot tries to make a pure rotation on a 10-degree incline during a 10-second. In the experiments, the robot slipped by an average 61.8 centimeters compared to 56 centimeters in the simulation. In this research, we analyzed the dynamics of small track robots moving over rigid surfaces, both horizontal and inclined. We developed a dynamic model in which all points of the track slide as the robot rotates. The results show that along the velocity range, the friction force is almost independent of the sliding speed. As a result, the simulation produced almost identical results for Coulomb's friction law and Luger friction model. The results show that the inertia moment, mass, and coefficient of friction have a very small influence on the turning radius over a horizontal surface. Over horizontal surfaces, the difference between the experiments and the simulations was less than 2%. Over inclined surface, for driving the error was similar, and for a pure rotation the error was less than 10%.